We're looking at two rational expressions this time that we're going to divide. And this is very similar to multiplying rational expressions with the exception that we're dealing with the division symbol. And if you recall, whenever we try to divide fractions, which is really what these rational expressions are, they're just fractions, but they have polynomials involved. But if you recall, when we divide fractions, we can't really divide. So what we have to do is we have to keep the original, or the first fraction, in this case, rational expression, as it is, 4x cubed divided by 9x squared y. And then we change the divide to a multiplication symbol, or multiply. But then when we do that, we look at the second rational expression, and we have to take the reciprocal. And what that means is we flip the rational expression. What's on the bottom, we put on the top, 9y to the fifth. And what's on the top, we put on the bottom, which is 16. All right, now we go back, and what we want to do is we want to look at, first of all, the coefficients to see if there's anything we can cancel out with the coefficients. So notice I have a 9 on the bottom here, and a 9 on the top here. We can cancel those out. And then notice I have a 4 here and a 16 there. Well, the common factor of 4 and 16 is going to be 4. So 4 will go into 4 one time. 4 will go into 16 4 times. And then we just multiply straight across. So I have 1 times, when I cancel the 9 out, that's going to be 1. So 1 times 1 is going to give me 1. But I really don't have to write the 1 because I've got variables. So now I have x to the third times y to the fifth. That gives me x to the third, y to the fifth here. Then on the bottom, when I cancel the 9 out there, it left me with a 1. So 1 times 4 gives me 4. And then I have an x squared y. I have to multiply and bring over. All right. Now, I have to look at the division portion of it, or the division process. Notice I have an x cubed on top and an x squared on the bottom. Remember, whenever we're dividing variables, we have to subtract the exponents. So I'm going to have on top, I'm going to have x to the third, and then I'm subtracting off the exponent here, so minus 2. And then notice I have y to the fifth here and y there. So that's going to be y to the 5 minus 1. And remember, whenever I doing the division, I gets rid of the variables on the bottom for now, but I still have the 4, so I have to keep the 4 in my denominator. And then let's simplify it one more step. I have x to the 3 minus 2. Well, 3 minus 2 is 1. And remember, when we have an exponent of 1, it's understood. We don't write it. And then we have y to the 5 minus 1 gives me y to the fourth over 4. That is my answer once I divide these two rational expressions.